signal, hoping the faint interstellar glow will reveal itself once the data are stacked together. In addition, both orbiters attempted something even more ambitious to measure the comet's light spectrum. However, it's still unclear whether the object was bright enough for those instruments to pick up meaningful spectra. However, the research continues. Over the coming weeks, scientists will keep reprocessing and stacking the data, searching for any clues about what 3Y Atlas is truly made of and how it behaves as it warms under the sun's radiation. In the meantime, on October 4, 2025, one of the navigation cameras on the Perseverance quietly captured something extraordinary, a thin glowing line that cut through the gloomy Martian sky. Now, NASA's NavCam isn't meant for astronomy. It is a robust camera that aids the rover in driving and route planning. The interstellar comet 3I Atlas was passing within cosmic shouting distance of Mars that night, however, as it scanned the Martian sky above Jezero Crater. The image is now featured as Image of the Week on NASA website. It looks long and symmetrical, as if almost engineered. But is it truly so? The rover's camera is designed to see tiny details nearby, but when it looks at something far away like 3I Atlas nearly 38 million kilometers from Mars during flyby, each pixel suddenly covers a huge chunk of space, about 12,000 kilometers across. The bright stripe appears to be approximately 4 times longer than it is wide in this picture. When you do the math, that makes it seem almost 50,000 kilometers long, way bigger than the object could be. And that's where the problem begins. Earlier measurements by the Sphere-X mission placed an upper limit on the object's true size at just 46 kilometers, assuming it reflects about 4% of the sunlight that hits it. As a result, the NavCam stripe is approximately 2,000 times longer than the actual object. In the July 2025 images taken by the Hubble Space Telescope, 3I Atlas would have appeared enormous at 23 arcsec across if it were truly a 50,000 kilometer long cylinder. Yet in reality, Hubble saw nothing of the sort. It appeared to be a tiny, undefined light point. That means the stripe couldn't be a physical structure. It had to be an image from a photograph. So the best explanation, a motion blur. To catch something as faint as an interstellar object from the surface of Mars, Perseverance's imaging team had to stack hundreds of short exposures over several minutes. During that time, 3 Atlas moved noticeably against the background stars. Even though images like these have circulated on social media, this Twitter account has processed the best image of 3I Atlas from the Perseverance mass camera. The link is in the description. A number of Mars-circling orbiters, including the Mars Reconnaissance Orbiter, were also pointing in the same direction that night. For a brief window, 3I Atlas became one of the most closely watched interstellar visitors ever, captured simultaneously from both orbit and the surface of another planet. But the image that may settle the size debate once and for all didn't come from Perseverance. It will come from the high-rise camera aboard the Mars Reconnaissance Orbiter, which achieved a resolution of about 30 kilometers per pixel during its October 3rd observation. That's more than 400 times finer than NavCam. Yet ironically, many NASA websites and feeds have gone silent, affected by a government shutdown at precisely the moment we need real-time updates. Shutting down key public access during an interstellar flyby feels awfully convenient, especially when researchers around the world are eagerly pressing to follow what might be the most unusual object ever seen in our solar system. There has already been a lot of speculation. Some people think it might be a comet unlike any other that is very active. Others propose more exotic ideas, a probe from beyond the stars, a piece of technology, or an alien craft. The timing of this blackout raises questions, regardless of whether or not those theories are true. Thankfully, we might have a lead. The Perseverance rover captured an image of a streak over a lengthy exposure sequence on October 2nd. The normal motion of Mars's sky background is not matched by that streak. This path is slanted and consistent across images rather than being vertical or aligned with the star trails created by Mars's rotation. It's real. It's not a glitch. It is moving quickly. The possibility that the 3 Atlas itself was what we saw is plausible. Drew deserves credit for pointing out this streak, as his tweet prompted additional investigation. The size of the object right now is unknown, but lower limit proposals cluster around 5 kilometers wide, possibly even wider. It lacks the typical comet's huge dust tail. Instead, it appears to be enveloped in a vast dispersed coma of ionized dust and gas. Its speed is extraordinary, roughly 60 km/s, accelerating toward a peak near 68 km/s as it nears perihelion at the end of October. Now, around September 25th, a coronal mass ejection struck 3 Atlas that may have ionized or energized its surroundings. However, images taken on September 27th and October 2nd show only hints of gradual envelope expansion, not a cataclysmic restructuring or sudden tail breakoff or fragmentation. That's why the NASA coverage meant so much to everyone. The object will be intercepted by the upcoming JUICE mission as it moves toward perihelion. However, sonar communications will delay much of that data delivery. Together, these assets could stitch a better portrait of 3 Atlas. For the time being, the mystery of the stripe doesn't have anything to do with alien technology, and it's not nearly as big as some people claim. However, how big is the 3 Atlas? It can be challenging to determine the actual size of a comet. The difficulty lies in distinguishing the nucleus from the hazy coma that surrounds it. As a comet draws closer to the sun, its frozen ices turn directly into gas, dragging streams of dust out into space with them, which forms their distinctive trail or coma. As a result, the comet may appear significantly larger and brighter than its solid body. Now, a Harvard team led by Richard Kluta, Avi Loeb, and Peter Vest looked at data from 3 atlases that were collected from 227 different observatories around the world via the Minor Planet Center between May 15th and September 23. They compared the actual trajectory to the one we would anticipate if gravity were to act. What they found was a tiny but noticeable push, less than 15 meters per day squared. However, the gas-escaping jets typically provide a slight push to comets that are actively outgassing. When compared to the outgassing that has been observed, the measured non-gravitational acceleration in 3 Atlas cases is surprisingly low. This suggests that the nucleus is sufficiently heavy to resist being significantly moved around by those jets. From this, the researchers estimate the comet's core weighs over 33 billion tons with a diameter of roughly 5 km, not counting the surrounding coma, appears to be about 3 to 5 orders of magnitude more massive than earlier interstellar visitors. Lowe has argued that given what we anticipate about the population and abundance of heavy elements in interstellar space, we ought to have encountered a much larger interstellar object by now, yet we haven't. Additionally, this makes 3I Atlas an important outlier. Lowe even entertains a speculative alternative that the object could be of technological origin, citing the unexpectedly large mass, the alignment of its trajectory, and some